Good evening, class. It's Rachel here tonight, and I'm going to be teaching you your lesson. We're going to be comparing and ordering fractions. So we'll take a look at a fraction and see how it compares to another by seeing if it's larger or smaller. And then we'll be able to order the fractions as well. So let's do a quick review here of our fraction terms so that we understand what's going on. Remember that the numerator is the number of parts being thought of, all right? It's always the top number of a fraction. And the denominator is the number of equal parts the whole is divided into, or it's the total. It's always the bottom number, okay? So for 1/6, remember the numerator is the 1 and 6 is the denominator. So let's just go ahead and dive into a few examples here. Here I want you to write 5 fractions that are equivalent to 1/2. Remember what equivalent means, okay? When 2 or more fractions are representing the same number or they have the same fraction value, they're equivalent fractions, okay? They're equal. So what fractions are equivalent to 1/2? Let's go ahead and write 1/2 equals, and I'm just going to choose any denominator that I want that I know that 2 can go into. So I'm just going to choose 4 here. Well, how did I get 4? I took 2 times 2 to give me 4. Now, since I did that on the denominator, I also have to do that on the numerator, okay? So I'm going to take 1 times 2 up here, and that's going to give me 2/4. Okay, so I know that 2/4 is equivalent to 1/2. Let's do another one. So let's set it up again. I have 1/2 equals, and I can choose any denominator I want. So here I'm going to try 12. How did I get 12 in that denominator? Well, I took 2 times 6, right? 2 times 6 is 12. So since I did times 6 in the denominator, I'm going to do it in the numerator. I have 1 times 6. This gives me 6/12. So I know that 6/12 is equivalent to 1/2. I'm going to do another one here. I'm going to go ahead and do 40. How did I get 40 in this denominator? Well, I took 2 times 20. So I'm going to do that in the numerator as well. I'm going to have 1 times 20 here. Gives me 20 over 40. And I know that 20 over 40 is equivalent to 1/2. That's how you find equivalent fractions, okay? Whatever you multiply the denominator with, you multiply the numerator with. That's our main rule. Whatever you do on the bottom, you do on the top, and it goes the same the other way around. Whatever you do on the top, you do on the bottom, okay? So let's take a look here at the bigger picture of fractions so that we understand what's going on. Here you can see what 1/1 looks like. It's a whole, right? You can see what a half looks like, a third, a fourth, a fifth, all the way up to a tenth. It's important that you can picture these, that you can picture the general idea of a fraction, because oftentimes students will see a 10 in the denominator, for example, and they'll think, well, 1/10 is larger than 1/2 because 10 is larger than 2. But look at the pictures here. Look at 1/10. You can see how much smaller that piece is in comparison to a half. So don't make the mistake that thinking a 10 in the denominator is bigger than a 2 in the denominator, okay? You have to think of it as compared to a whole. And I know a lot of you are really good at drawing out these pi circles already when you're answering questions about fractions, and that's really good. Just remember how to picture these when you get stumped on a fraction problem. Here is another example. You can see what 2/3 and 4/6 looks like. Look at the pizzas. You can see the one on the left is cut into 3 pieces, and there's 2 pieces left. The other one is cut into 6 pieces, and there's 4 pieces left. But you can see that they're equivalent. We know that 2/3 is equivalent to 4/6. So let's go ahead and compare these examples here. We have 6/8 and 7/8. When you're comparing fractions, you have to remember to look at both the numerator and the denominator, okay? If the fractions have the same denominator, like we do in this example here, they both have 8 in the denominator, then we can say that they have like denominators. So for 6/8 and 7/8, since they have a like denominator, all we have to do is look at their numerators. Is 6 or 7 larger? Obviously 7 is larger. So we know that 7/8 is greater than 6/8. So let's go ahead and look at a picture here and see how that looks. You can look at these pizzas and see 7/8 is clearly larger than 6/8. Let's go ahead and do another example here. We have 1/4, 1/8, and 1/16. Which one's the largest? Which one's the smallest? Well, let's think. Most people might think that 1/16 is the largest because 16 is the largest number. It's larger than 4 and 8. But let's look at a picture here. Here you can see what 1/4 looks like, what an eighth looks like, and what a 16th looks like. Which one's the largest? Well, obviously the fourth, it's taking up the whole right corner of our pie. So this tells us that a fourth is much larger than an eighth and a 16th. You can see how small a 16th is there. Okay? So don't make the mistake of thinking that a large denominator means a large fraction, because that's not necessarily true. Let's look at another example here. We have 5/8 and 3/4. Which one's larger? Well, let's do this one without a picture to help us. When we're comparing fractions with different denominators and numerators, we need to find that common denominator in order to compare them. So we have to find a common multiple that both of these numbers can go into. So what's a number that both 4 and 8 can go into? Some of you might think 32 right away because you know that 4 times 8 is 32. So that both of these numbers will go into 32. And that's true. But we can also find a smaller number. Both of these numbers will go into 8, right? 4 goes into 8 twice, and 8 goes into it once. So let's go ahead and change these denominators. We don't have to do anything with 5/8, right? Because that already has an 8 in the denominator. But how are we going to change 3/4 to have an 8 in the denominator? Well, we took 4 times 2 to get 8, right? So we have to do the same thing to the numerator. We have to do 3 times 2. That will give us 6/8. So what's larger, 5/8 or 6/8? Obviously 6/8 because 6 is greater than 5. So this tells us that 3/4 is greater than 5/8. Let's go ahead and look at a picture here to see what that looks like. You can see that 3/4 is clearly larger than 5/8 from these pie graphs. Let's go ahead and do another example here. We have 1/2 and 1/4. What's a common denominator that both 2 and 4 can go into? You might think 8, 12, but let's just go small. Let's just go ahead and do 4, right? They both go into 4. So how are we going to change 1/2 to have a 4 in the denominator? We're going to take 2 times 2, right? So let's do the same to the numerator. We have 2 times 1. So that gives us 2/4. We have 2/4 over here. We don't have to do anything with that because it already has a 4 in the denominator. So we know these two are equivalent, right? Let's look at the picture here. You can see that the pie on the left is cut into 2 pieces. And the one on the right is cut into 4 pieces, but they're both showing the same amount shaded in, so we know they're both equivalent. So now let's work on ordering fractions. We have 3 fractions here. We have 3/12, 10/12, and 6/12. We have to order them from smallest to largest. Well, they all have the same denominator, right? So all we have to do is look at their numerators and order them from there. Which one's the smallest? Which one's the largest? Obviously, 3 is smaller than 10 and 6, so we know 3/12 is our smallest fraction here, and we know 10 is larger than 6. So we gotta shift these two here, and now we have them ordered from smallest to greatest. It's pretty simple when they all have the same denominator. Now, what about these ones? We have 1/4, 3/7, and 2/5. This is kind of a tough problem because I don't know about you, but I don't know a denominator, a common multiple that all of these can go into. What's the number that 4, 7, and 5 can all go into? So let's go ahead and take a look at 2 of the fractions and work from there. If we take a look at 1/4 and 3/7, we can compare these two and see which one's larger and which one's smaller. So we got to find a common multiple that both 4 and 7 can go into. How about 28? What did we do to get 28 in that denominator? Well, we took 4 times 7. So since we did it in the denominator, we have to do it in the numerator. We have 1 times 7 gives us 7/28. Go ahead and do the bottom one here. How do we get 28 in the denominator? We took 7 times 4. So since we did in that denominator, we're going to do it in the numerator. We have 3 times 4 up here. That gives us 12/28. So this tells us that 3/7 is larger than 1/4, right? Because 12/28 is larger than 7/28. Next, we're going to look at the other 2 fractions here. Let's compare 3/7 and 2/5. What's the common denominator that both 7 and 5 can go into? 35, right? We know that 7 times 5 will give us 35. So let's do 3 times 5 to give us 15. Go ahead and do the other one here. How many times does 5 go into 35? 7 times. So let's do 7 times up here. 2 times 7 is 14. So let's take a look here. We know that 15 is bigger than 14. So this tells us that 3/7 is larger than 2/5. So we have to switch these two here. Now we have them ordered from smallest to greatest. This problem was a little more challenging because there is so much math involved. So it's really important that you try to keep your homework organized and make sure that you're taking your time. Okay? The last thing I want you to look at here is this chart. This is called a fraction stick chart. It's something that you'll be working on in your math journals tomorrow. You can use this chart to find equivalent fractions. Okay, so what you do is you first locate your fraction. Let's go ahead and use 3/4 as an example. It's right here. What you want to do is you'll want to use a straight edge and make a straight vertical line all the way down. I don't have a straight edge, so that's my attempt at making one, but when you work on this tomorrow, you're going to make sure you use a straight edge. So what we're going to do to find our equivalent fractions is see what sticks here will meet up with our vertical line. Obviously, we have 3/4, but we can also see that 1/8, that stick will match up with our vertical line. So let's count. We have 1, 2, 3, 4, 5, 6. So we know that 6/8 is equivalent to 3/4 because it meets our vertical line that we just made there. Are there any other ones that meet up with our vertical line? The 12th row does, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that 9/12 is also equivalent to 3/4, and we can see in the 16th row that that also meets up with our line. Count those up, we get 12/16. So we know that these four fractions are all equivalent from using this chart. And we'll work on that a little bit more tomorrow as well. I just wanted to give you guys a little preview into that. So remember the rule when we're finding equivalent fractions. Whatever you do on the bottom, you must do on the top. Whatever you do on the top, you must do on the bottom. Please take your time doing your homework tomorrow. Don't just guess because it's very, very easy to guess wrong when working with fractions. So make sure you show your work clearly, try to keep it organized, and I'm looking forward to working on this with you tomorrow.